Hello friends, welcome to C Sharp Intermediate to Advanced tutorial. Now you are watching final part of the video, ICloneable interface. Now we will implement the last part of the example and we will learn how deep and shallow copy works when object contains reference data type. So these are all the slide decks from previous parts. First we learned about value type and reference type. Then we learned about the ICloneable interface and the role of deep and shallow copy. Then we talked about member-wise clone. After that we talked about the example, and by this time we implemented the top portion. Now we are here to experiment the deep and shallow copy with object containment having a reference type. Now we will create a new class called line which implements ICloneable, and if you see, this line class contains two reference type. So the line is represented by 2 points, and we make use of our previously created class point 2d, and we know that it contains two member x and y, both are value type. So here if you see clearly, we have a line class, and the line class contains two reference variable. We say this is pt1 and pt2. Since it's a reference type, this will point to some other location, and this location contains x and y. We call it as a CLS point instance. Similarly, there is one more CLS point instance that contains one more x and y. So there are three objects involved here, or three objects in heap. One is a line. So when user constructs a line object, that will go to heap. Then the line contains two reference member. So the reference member will get created in a heap, and the address of that heap gets stored here in reference variable pt1 and pt2. So totally line, that's one CLS point, second CLS point. There are totally three objects involved. So next we have a constructor for line that takes two CLS point and initializes the internal data member. So if you see here, whoever is calling, they will create these heap locations. That means they will create new instances of points, and they pass that to the constructor of line. So this means, let's say for example, 0k and 0n are the locations, and whatever the caller pass is that location, 0k and 0n, and that location only we are storing here. That means in pt1 reference we store 0k and 0n. This means whoever is calling or whoever is constructing this line class, they already have a heap location for these 2 points. And when they pass those two reference variables, they just pass the address, and the address get stored inside the line class member. That's why you see this indirection. All right. Next we have override for toString, and here we are printing the content of P1 and P2. There are 2 points, right? So we call first point as P1, second point as P2. Then we specify its X and Y coordinate. So it will print like this: P1, for example, 5,10, then an hyphen. After that, P2, 12,6. So just by looking at this, you can say this is a line object denoted by 2 points, point 1 and point 2. Point 1 coordinates are 5,10. Point 2's coordinates are 12,6. That means x12, y6. So after this line object definition, we can implement the clone method on the line object. Remember, we previously implemented this clone method for our point class. The point class had 2 internal members, X and Y. Both are primitive type and their data types are integers. So we can say point contains value type as member. But here line contains 2 point objects. Point objects are not value type, they are reference type, because the object will be constructed on the heap and we store just the address in a reference variable. Alright, now here we are calling member-wise clone on line object. And finally, we are returning that line object. Now let's say what happens. Okay, here we will be calling L2.clone and we will perform typecast here. Now let's say this is L2, we will say like that, and this one is L1. So line L2 equal to L1 dot clone, and returned value we are storing here in line 2. That means let's say this is line 1, which contains 2 point PT1, PT2, and this one is line 1, which is the source. As you see here, the source object, that means line 1. So this line 1 itself will be in the heap, and that has 2 compartments. And compartment 1 is storing address of some other heap location. Let's say this is H1, heap location 1, and heap location 2, H2. And compartment 2 is storing some other heap location H2. And here we are calling member-wise clone. So we know that what this member-wise clone will do. The member-wise clone will create a new instance. That's the first duty of source. That means here we will be getting an object of type line in the destination. This will have 2 compartments, PT1 and PT2. Previously we saw when we implemented the clone, the member-wise clone performed a bit pattern copy. When it performed a bit pattern copy, it copied the integer values X and Y, it directly copied. Since the compartment content is a value itself. When we copied it, we doesn't see any problem. But here compartment content is not a value, it's a reference. So this is the PT1, but PT1 stores address H1 that is pointed by this PT1. Now when member-wise clone takes place, what happens? This PT1 copies the address location, so H1 will get copied here. That means here will be pointing this, and here also we will be pointing to the same location, H1, H2. So then finally we will return this object to the caller. The caller will refer this as line 2. After it is returned to the caller will refer. Return value is referred as line 2 at this stage. Alright, so that's what member-wise clone will do. Here if you see, it produced a shallow copy and you are seeing a problem. So the caller, when they change some content, it changes the content of the original copy also. That means it will change the content of L1 if the caller modifies X and Y through line 2. Alright, so we know that our point 1 already implemented clone method. So if you see here what we are doing, PT1, this is line 1's PT1, we can access a point 1 instance, then we are making call to its clone method, and we are typecasting that as point 2d, then we are storing the return value to PT1. The same we are doing for PT2 as well. To better understand this, let's once again go with the same statement, line. So we saw the problem when we doesn't add the code snippet 14.8. Now we will see what happens because of this 14.8. Previously, the member-wise clone, after calling this, the memory architecture will be like this. So this will still perform the member-wise clone on the containment, and both will point to the same location at this stage. So this is the new object in heap. Now here what we are doing, pt1.clone, this means the calling instance. Here we are calling, right? This dot clone, that means pt1.clone, you are making call. That means it will make a call to member-wise clone, which we implemented in the previous video for the CLS point. So the rule is still same. Here if you see, when you make a call to clone method, the clone method creates a new instance in the heap for line object. Here you are making call to the CLS point 2d clone. That means it will create a new instance. Now if you see, this is the source. Here this one is the source. Now we are talking about this particular line. So this is the source. From source, the clone method will call the clone method of CLS point 2d, and we know that inside we have a member-wise clone. So it creates a new location. Let's say that this new location is H3 and this is a destination, or let's say it's H3, new heap location, and it copies the content. This is value type, right? So you won't see any problem here. The content will get copied, and the member-wise clone, the clone override of CLS point 2d returns this new heap location. We are typecasting that, and we are storing that on pt1 of the destination. Here we already have destination, right? Remember, the destination here is the heap location on line object. So previously at this line, pt1 pointed to the h1 location. Now since we make a call to member-wise clone on a particular member, that means here particular member is CLS point 2D. We get a new heap location for CLS point 2D, and that heap location is copied because it's a member-wise clone, right? Inside we are making call to member-wise clone on CLS point 2D. So the content will get copied. After that, this object, that means this destination, this will get returned to the caller. The caller is here the clone of a line. So the returned value is stored in here. We have the return value, right? This is the return dot pt1. Return dot pt1 means this is the new object in heap. Member-wise clone, we already told it will create new instance. So this is the new instance. So this is snapshot is at this location. Now we are talking about the second snapshot. Alright, now we are here, right? Return.pt1. Return.pt1 is this equal to whatever is returned by the member-wise clone of CLS point 2D. That means h3 is stored here. Previously it was h1, now it is h3. That means now it is pointing to this new instance. The same happens for this second line also. So we have a new memory location h4, and we have two compartment x, y, and pt2. Previously it was pointing to h2. Now it is pointing to the new location h4. Right. So if you see, now we achieved deep copy just by introducing the code snippet B. So if your point object doesn't have the clone method implementation, then you have to manually create a new point and assign that here on P1 and P2. Then you have to manually copy the content X and Y. So that's why when containing reference type object implements clone method, it will be easy to make a call to clone. Alright, now we will see the code. Here if you see, we are creating point 1, we are assigning the members. Then we are creating point 2, we are assigning point 2's member. Then we are creating line object by passing the address location. Here let's say for example, we talked about h1, h2, right? Let's say this is h1, this is h2. Just for example, let's assume the memory location. So h1, h2 is passed here, and when we are in the constructor of line, here let's say this line itself will get constructed at some memory location. Let's say it's h0. And that h0 memory location points to two memory location, which is h1 and h2, right? So that's what we did here. We already saw that when we talked about the line class. Now here we are just doing the assignment. We don't need to experiment this because we already did this in the CLS point 2D itself. Now here if you see, we are making call to clone method line 1, clone line 2, right? So we know that what happens. First the clone method will be called 3 times. This is for line 1, that's the source. Then for point 1, then for point 2, right? So this means in all the clone methods we are making call to member wise clone. That means there will be new heap location. One is for line and one is for point 1 and another one is for point 2, right? And this new location points to these two new point location. That's what happens here. And finally this line, so here we are calling l1.clone, line1.clone. So this will return this object to the caller. and we store that in line 2. Now line line 2 is the clone of line 1, but they are both are independent. So this is line 1 and this is line 2. This is pointing to some location xy, I mean 2 point, and these 2 points points to some location which has compartment x and y. The same goes for this. So both are independent object and you can work freely. So here you will be having the exact copy. After A, you can change the content freely. So if you change the content of L2, it won't affect L1, or if you change the content of L1, it will not affect L2 because of DeepCopy, which we performed in the previous step. This is just a testing piece of code. After the clone here, we are trying to change the content of point 1 on line 1. Then we can check L2 object is changed or not. Here we will simply debug and see how it is working. Alright, now it's demo time. We will go ahead and see how it works. First we will implement the code change, then we will put a breakpoint and see the working of a deep and shallow copy. So here is our example. Previously we implemented the top portion of this example. Now we will concentrate on this one. Before that, we will create a new class and we will call this as a line. And this will implement ICloneable. Previously, we had a point class that contains two primitive or value type. Now, if you see, this contains two reference type, point 1 and point 2. A line is represented by 2 point, and CLS point, if you see, the members are integer primitive type. It's a value type. Members are value type. Here, members are reference type. So the constructor, we are initializing this line with two incoming point objects. Then we have 2 point overrides, I mean 2 string override. Here we represent our line object in terms of point 1 and point 2. Finally, we implement clone method, and this was already explained in detail in the PowerPoint slide. We will build it once. Now we will go ahead and implement a click event for this button, and we will experiment our line objects. So here I am keeping a breakpoint, and we will click on debug. We should have used these points, but anyhow it's okay. Here we created a new points. Okay, that's all right. Now let's click here, and if you see here, I am in the immediate window, and we can go to watch window also. In watch window we already have, okay, let's say when you open watch window it will be empty. here what we can do is we can put a watch for line 1. So just double click here, drag and drop it to the watch window, then click on line 2, drag and drop. So you can see the value how it is changing. At this moment we are constructing point 1 and it is uninitialized. Now we are executing these two lines, and after that if you see, this is our pointer. X is 5 and Y is 5. So now we have 2 point objects in the immediate window. If you want, you can type the content pt1 and it shows CLS point 2D and its content. If you want to type address, you can place an ampersand, then put pt1. So this will show the association of the heap. So on this heap location, this pt1 will be constructed and it will have 2 compartments, X and Y. So that happens on this specific location. And if you see, this is a different memory location. Why? Because we created 2 point objects. Now here we are constructing the line object, and the line object will be at a different location. And in the watch window you can see line object is constructed, and value if you are seeing value, if you see here, it denotes line in terms of p1 and p2. This is because we implemented a toString here. So our debugger makes use of this toString and shows this in the format we want. Alright, now we will go back here. Now we are going to the clone method, and we can keep a breakpoint of clone here. We will keep a breakpoint of clone implementation on point object also. Alright. Now I will simply click on step over. Since we have a breakpoint at required location, we will land up there. And if you see, we are at line classes member wise clone method. That's all. Now we can check the return value. So at this stage, we have this pointer, right? All right. So this dot pt1 is 5, 5 and question mark. This dot ret dot pt1. So both are showing the right result. Let's do the clear. If you see what this proves at this stage, this dot pt1 is the caller so the caller here is line 1, right? So line 1 is this here. This dot pt1 from line 1 pt1 is showing an address and the return value. So whatever member wise clone created, that is the one which we stored here as RET, and here we are asking give me the address of pt1 which is contained inside this return value. So that is also, if you see, pointing to the same location. And this one is the line 1 object and this is line 2 object. This is okay because we are inside the member wise, we are inside the clone method of line 1. So we called the clone method from this location, from this address location, the line 1 address location. Line 2 address location, whatever it returned, that's different. So these two are two different heap location. The line object, line 1, and this is what we are going to return, the line of return. But here pt1, if you see, the source and the destination both are pointing to the same location. Now we are going to avoid this by calling the clone on point 1 and point 2. Let's execute. So here it is calling member wise clone of our point. Next it will once again call. Alright, now we can evaluate these two expressions once again. Let me call clear. If you see, now the address is changed, pt1 5e10, and the member wise clone on individual reference type object created a new location. That means the source objects pt1 and destination objects pt2 are pointing at a different heap location. They may have same value because the clone will perform same operation. So for example, this is pt1, pt2. Alright, in the return we will check that. Now we are done with this and we will go to our watch window and you can see line 1, line 2. Now here we are changing the content of line 1. See, line 1 got changed and it doesn't disturb line 2. Why? Because we did deep copy, so the point instance is now not showing at 2020 1010. So these two are now different because of deep copy. And you can experiment this by commenting these two lines. So if you comment these two lines, it will perform a shallow copy on the internal member, and you will be seeing here at 2020. So when you change line 1, it will change line 2 also, or if you change line 2, it will change line 1, the internal members. So now you have an idea of shallow and deep copy and how to implement cloning properly on value type as well as reference type. So the example here shows value type related one, and since it's a value type, the member wise clone works well. But if it is a reference type, then you have to avoid shallow copy problem by performing the clone, or you have to create the new instance here manually and copy the content. That means create a new cls.2d and copy the content from the source this dot pt1.x to destination.pt1.x. After that you have to return, but instead here we just made use of the clone method. That's all here in this video. Thank you for watching. Bye.